I am Dr. Jyoti. I am the founder of TeraLumen. Pure tech background. I have completed my PhD from CSIR Siri. 2019 I have started the company thinking of making indigenous products instead of importing from other countries out of the from UK, US. Problem statement we are working on, that is cancer margin detection. This technology will help us in various applications including cancer margin detection. Breast cancer is the most common cancer. Similarly, among the men, specifically in India, oral cancer is the most common cancer due to the tobacco and other things. If you see the conventional method, they will remove the cancerous tissue. So conventionally, they go for histopathology assessment or frozen section analysis. But here, the problem is the doctors do not know whether the entire tumor tissue has been removed or not, because they cannot visually see every tissue. That's why sometimes the cancer surgery may fail. Around 30% of cancer surgeries fail due to inaccurate margin detection. In that case, when we will go for pathology assessment, which is time consuming, it will take several days, 3 to 5 days, depending on the hospital, it may take a week. After 1 week, they get the confirmation whether surgery is successful or not. If it is not successful, the patients have to go for second surgery or failure in surgery. So there is not any single device has been developed across the country, even worldwide also, who can tell that yes, the cancer surgery is clear or not. So that's where TeraLumen is doing a major role here. So how TeraLumen device is working, the name is TeraMargin. TeraMargin is using Terahertz technology, you can do the margin analysis. So what TeraMargin does, TeraMargin, once the sample is excised, we have a sample holder, we'll do the raster scanning by using two motorized tests, X and Y. So basically the sample will be moving X and Y once, it's like a serpentine motion. Every pixel of the sample you will have 1 terahertz intensity, and that intensity will vary. You will have a heat map. The intensity will have higher frequency range if it is a malignant tissue, it is low frequency if it is a benign tissue. So if we will have a heat map, the red portions of that we have a threshold value, we will say that yes, above the threshold value it is tumor, below that is benign tissue or it is safe tissue, it is healthy tissue. So heat map itself will give you, as I said, pixel by pixel. So every point of the sample, it can maybe 1 mm, it may be 1.5 mm. You can say that 1 mm of the tissue is tumor or that mm is non-tumor. Your AI will tell the real time will have a segmentation. That segment is having tumor tissue. It is a device which you can place inside the operation theatre. The radiation is completely safe for human body. Having safe means it's non-ionizing and non-invasive. Non-invasive means we are not going to touch the samples. So complete non-contact. So as you see, you need an extensive pathology lab, you need an pathologist. So this system will simplify all the problem statements. You do not need to add any reagents, you do not need to fix the sample, and you do not need the freezing of the sample. So the technology itself will give you whether the entire cancer is removed or not, without adding an expert pathology lab or an expert pathologist. As you know, number of surgeons are very less across the country. Surgeons' time, everything can be reduced, and as I said, pathology lab and pathologist effort, everything can be reduced using this device. The motto of the company was to build the product indigenously. Product means it combines both hardware, software, AI. We build the hardware, along with that we make our own graphical user interface, which will help the surgeons to visualize in either their laptop or in their mobile. The real-time images they can visualize. On top of that, we apply our AI algorithm into that so that the doctors can take the real-time decision immediately within 15 minutes of the surgery. What I said, accuracy means till now we have done more than 150 cancer tissue samples. It is real human tissue samples, on fresh tissue samples. When we are doing the 150 tissue samples, now we are getting more than 90% accuracy. Our sensitivity is, we are about to reach 95% sensitivity now, our AI. The conventional method, that's margin probe, is giving 70 to 75% sensitivity and I think 75 to 80% specificity. So that is one, the accuracy level is very high.
I'm Dr. Nishina Raghavan. I'm presently the consultant and head of department of Narayana Health, Bangalore, histopathology and cytopathology department. So conventionally, we have what is called the intraop assessment of margins. This is based on what technology we follow in the lab. It is called the frozen section technology. Now that particular sample comes to us and then we examine it as a histopathologist. It takes about 20 to 30 minutes, depending on the size and the number of specimens sent by a surgeon for intra-op assessment for margins. The gold standard remains what we do post-operatively, that is the regular histopathology permanent section examination. Now that takes about 2 to 3 days because it involves a lot of steps so that a section is created and the histopathology reads it. The freezing takes about 15 to 20 minutes per section. Now that freezing time can be avoided in a TeraLumen device where there is no involvement of freezing medium or any other reagent that will help. So as of now we have tested about 140 samples, the maximum being the head and neck samples and the remaining are breast specimens. We are presently evaluating what is known as whether the machine can pick up whether it is benign or malignant, and also we're doing the intraop assessment of margins by calculating the distance and presenting it as millimeters from the margin. So presently we have evaluated, so this is the first phase of the project which has been given to us. So as a histopathologist right now we are validating the data whether there is tumor or no tumor first. So in that we have seen the sensitivity of the machine is quite good, 93% maybe, 83 to 93%.
And going forward, we're planning to make as cost effective as possible, since because we build the product here in India. We make it cost effective, we made it simple, made it compact. So it took around 2 to 3 years to build the product, where the product can be placed in the hospital environment. Once the product was ready, then we started talking to all the hospitals across the country.
Hi, my name is Fanindra Kumar. So I'm a mechanical engineer. I have a 16 years experience in sales and marketing. I have recently joined TeraLumen to develop this business, the product what we have on the Terahertz technology. TeraLumen is the only company who has such a portability in the instrument, the whole technology instrument, which can be used anywhere in any labs. So that is where the TeraLumen adds a value to the market, and this is where they bring the whole solution as a single product.
So I am helping the surgeons by reducing the surgery time. I am helping the pathologist by making the process much more simplified. I am helping the patients by reducing number of second surgeries and by taking the informed decision on the operation theatre itself. So I am seeing TeraLumen device all across the country.